Welcome back. In this set of videos, we're going to be looking at graphing reciprocal functions. Reciprocal functions are functions of the type y is equal to 1 over x. If we start by thinking about what values of x are not possible in this graph, we want to think about what we talked about with rational functions, and that's that we can never divide by 0. So what values of x are not possible here? And that's just going to be that x cannot be equal to 0 because I cannot divide by 0. When we ask ourselves the question, what values of y are not possible, we have to be a little bit more creative. So if I think about multiplying both sides of this equation by x, I can rewrite my reciprocal function as x times y is equal to 1. And if I think about this idea of x times y is equal to 1, I can go back and kind of revise my reason of why x cannot be equal to 0. 0 times any number cannot be equal to 1. 0 times any number is 0. If I use this reasoning, I end up getting that y can also not be equal to 0 because any number times 0 can't be equal to 1. So when I use these two, when I've got this information about what x and y can't be, we are going to find out that we will end up having asymptotes in these graphs. So based on this information, I know that I'm going to have some asymptotes in my graph. So I'm going to keep all of this key information over here, and we are going to look at the example, the basic example, graph y is equal to 1 over x. So y is equal to 1 over x. This is the same thing as x times y is equal to 1. Now, our domain restrictions, x cannot be equal to 0. And y cannot be equal to 0 is our range restriction. Other than those restrictions, we have all real numbers. So now I want to kind of think about what happens as x gets really big and as x gets really small. Or as x gets really big positive and really big negative. So if x is equal to 1, y is equal to 1. If x is equal to negative or to 10, y is equal to 1/10. If x is equal to 1,000, y is equal to 1 over 1,000. And what you'll notice is these numbers are getting really small, but really small and still positive. So as x approaches positive infinity, y approaches 0, but there's zeros that are just a little bit positive. And if I look at negative values, so x is equal to -1, y is equal to -1. 1 over -1 is -1. If x is equal to -10, y is equal to -1 over 10. If I plug in -10, I get a negative number. X is equal to -1,000, y is equal to -1 over 1,000. So as x approaches negative infinity, y still approaches 0, but it approaches 0 and is a little bit negative. We're going to keep that in mind in our graph. So now that I kind of know what's happening when x gets really big, I know what's happening when x gets really small, I want to think about my actual graph. The first step in all of these graphs is going to be graphing the asymptotes. So I'm going to go ahead and graph my asymptotes on here. So you can't totally see my asymptotes, so I'm going to extend them beyond. We're going to graph our asymptotes with dashed lines and label them. So this is the line x is equal to 0, and this is the asymptote y is equal to 0. So we have a vertical asymptote at x is equal to 0 and a horizontal asymptote at y is equal to 0. And those came from my domain and range restrictions. So now that I have those, and this is my only domain restriction, I'm going to have a graph that's over here and a graph that's over here. I already know that my graph is approaching 0 from below as we go towards negative infinity, and 0 from above as we go towards positive infinity. So I already have my end behavior over here. So I am going to break this table up with x is equal to 0 as my divider. So I'm going to have negative x values and positive x values. So I'm going to start with x is equal to negative 1. That's 1 over negative 1, which is just negative 1. So I have the point negative 1, negative 1. If I plug in negative 2, I get 1 over negative 2, which is negative 1/2. So negative 2, negative 1/2 is right there. If I plug in negative 3, 1 over negative 3 is negative 1/3. And you can see I'm getting closer. So I can follow this and approach that asymptote from below, heading that direction. I want to know what's happening between negative 1 and 0. So if I plug in negative 1/2, I get 1 over negative 1/2, which is just negative 2. And if I plug in negative 1/3, I get 1 over negative 1/3, which is negative 3. So my graph approaches this asymptote. So it's approaching 0. As I get closer and closer to 0, my y values get closer and closer to negative infinity. And I'm going to repeat this on the other side. So I plug in 1, 1 over 1 is just 1. I plug in 2, 1 over 2 is just 1/2. I plug in 3, get 1/3. So you can see I'm approaching this asymptote there. If I plug in 1/2, 1 over 1/2 is 2. So I've got 1/2, 2. If I plug in 1/3, 1 over 1/3 is 3. So it looks like that. And a couple things you want to note with this graph. So we've got a general shape that looks like this. So I've got kind of a soft L shape in each quadrant. If I folded this, if I took this and I folded across this line here, y is equal to negative x, the graph would lay flat on top of each other. So I've got mirror images in these two quadrants. It approaches these asymptotes, but it doesn't touch. So it kind of goes from one asymptote and curves to the other asymptote. This is going to be the general form of all reciprocal graphs. So I'll see you in the next video to look at what to do when they get a little more complicated.